I received a few inquiries on some things that people have been having issues with lately, and it all pretty much ponies back to not understanding the basic concept of how routes get from one place to another. Now, it's the most very basic concepts out there. You know, you've got static routes, you've got default routes, and you've got dynamic routes. There are three distinct differences between each one. Where a static route, you're taking a route coming from here and you're pointing it here. Meaning, so if you want to get to this IP address, this subnet right here, you have to tell this router that is going to go to this IP address via either this interface IP address or this interface physically. Now, by doing that, if you put in there the IP address of this guy, it has to do a ARP lookup when it goes to the routing table and say, what is the IP address for router 1 serial 000 interface? And it says, okay, the MAC address is whatever dot dot dot, 1.1.1.1 if it was a MAC address. That saves it here in router 0's ARP cache. So when the request comes in to get to this subnet address, that all this router has to do is say, okay, is this IP address available? Send. That's all it's got to do. As long as it has a layer 3 and a layer 2 address to send to, your packets will get forwarded. Now, if it does not have a static route, the packets will get dropped because it won't know how to go there. It'll say anything that is not destined, or I'm sorry, not that's more of a default route. But if you have specific IP ranges you want to get to, you need to have it configured to get from one router to the next. Even though this is directly connected, it needs to know how to get there. Routers are not that smart. You have to tell them what to do. Same thing with switches and computers. You have to tell them what to do. You know, there's an operating system. There's a certain amount of syntax there for it to run off of. It knows what threads are running what programs and turning things off or turning them to memory and so on and so forth. And that's the basic operation of an operating system. But beyond that, you have to understand the concept of getting information from one network to the next. Now, by rights, this network right here and this network right here are two totally separate networks. They're directly connected to the router, but because they're on fast Ethernet interfaces and there's ARP inspection caches, meaning when anything from this network wants to talk to this network, it knows about the MAC addresses on this network because of the fact that it's directly connected to it. Now, people often ask, why do I have to tell router 0 about router 1's serial interface, the MAC address? What does that matter? Well, like I said, in order for a packet to leave router 0 and go to router 1, it has to know both logical and physical address of the next hop router. If it doesn't know that information, it won't know what to do with it, because the logical operation of it going from router 0 to router 1, the IP address never changes. So this is the destination IP address. From hop to hop, it's changing layer 2 addresses each time it moves. So when it comes in here, when it leaves switch 1 and comes to router 0, it has the destination of fast 0's MAC address. Once the packet comes in fast 0, it rips the source and destination MAC addresses off and sets the source MAC address on the MAC address header, the layer 2 header, to the source of fast 0 and the serial interface MAC address here. Then it forwards it to here. Same thing happens. This becomes the source. This guy becomes the destination. If it doesn't know the destination MAC address, or layer 2 address in that matter, it has to ARP for it and say, hey, what is your IP address 10.13.1? What is your MAC address for your interface? Well, he goes, oh, it's this. Sends it back across the line, and it goes into the ARP cache. So then he's able to do an ARP lookup and say, okay, I know what it is now. ARP is Address Resolution Protocol. It is layer 3 to layer 2 lookup. Now there's reverse ARP where you're going layer 2 to layer 3. I know the MAC address, I just need to know the IP. So that's the basic concept of how packets are forwarded from one place to another. Very simple concept to understand. What most people get hung up on is the transference of MAC addresses. The MAC address is physical, which means it doesn't go anywhere. The IP address can be put wherever it's needed to be put. It's not something that's fixed. You can do a static mapping to an IP address, like I have here. Now, this is a point-to-point connection. As you can see, everything's up and running. The difference between a static IP address and a static MAC address is a MAC address is burned into the card, the network card on the interface. So the interface on this guy, the interface on this guy, so on and so forth. That can't be changed. Now, you can spoof a MAC address and stuff like that with some programs that are out there, but it's not going to be the same carry through that an IP address will have. So that's where a lot of people get hung up. So what I've done is I created this little lab just to give you an idea of what you could look at. Now, a static route, like I said, is saying in order for this network to be able to send packets to this network, it's going to ship it out this direction. So it has to say IP route. You're going to say 25.31.26.21/28, which could be a public IP address, and you're going to say you're going to get there by, you could say the serial 000 interface of router 0. You could do that. Now, if you do that, it's going to need to know the IP address of this guy, because it's a point-to-point connection. It's going to know that it's a /30, that the other IP address is this. It's going to know about that. Now, it's not going to know the MAC address. Why? That's a good question. Now, if you turn this guy on, I know there's a way for serial interfaces to learn ARP lookups, and they call it SLARP, is the technical term for it, Serial Link Address Resolution Protocol. Same thing as this guy doing it, and you saying, okay, in order to get from to this guy, you're going to go across the line and you're going to grab this. So, what's the point? Well, that pretty much is the point. So what I'm going to do here is I'm going to exit out, and I'm going to bring router 0 into the frame here. And what we're going to do is we're going to do a do show IP route. Well, what does it know about? It knows about the 3.0 network because it's directly connected. Now, can I ping? Can I ping 10.1.3.1? I can. How does it know? Because it's directly connected. Can I ping this guy? 25.31.26.21. Or, no, I'm sorry. It's going to be .2. Right? I have to double check my IP address settings. 26. 26.2, which is what I have in here. And as you can see, it died. Nothing happened. Why? Well, because it doesn't know how to get there. It's real simple, right? So what we're going to do on router 0, you go config T, IP route. This is a static route. So to get to 25.31.26.20 or .2, 255.255.255.240, you're going to leave out. You can put serial 0/0/0. It'll take it. Inconsistent IP address and subnet mask. That's weird. 240. Yeah. It's the right mask. Oh, wrong one. 3.1. Inconsistent subnet address and mask. Well, that makes me wonder. Bring router 1 into the picture. Enable show IP interface brief. Show run. .240. It took it. Ping 25.31.26.2. See, it works. 240 mask. Who would have thought? That's just weird that it won't do that. Oh, see, you know what? I could kick my own butt sometimes. Because you gotta put the base subnet in. See? Nothing to be worried about. You can't put a host IP address in there. There. Now, we're gonna go, this is router 1. I'm gonna close that guy out. This is router 0 still, okay? We're gonna do end. We're gonna ping. Now it goes through. Because now it knows how to get there. Now, there's no static IP address or static route to get back here. So, if this guy wanted to send this guy something, how would it do that? Well, it wouldn't be able to. Right? Am I close about that? Let's bring it back in here. And we're gonna ping 10.1.1.1. And nothing. That's what I thought. I'll finish up. We're gonna go config t IP route, and we're gonna go 10.1.1.0 255.255.255.0. We're gonna type in 10.1.3.2. No, there it goes. I must have had the right IP address. I couldn't remember what the IP was on that one. But see, as you can see, that's how a static route goes. Now, I'll throw one more in just for good measure. I won't do dynamic routing because there's just not enough time in this video. But dynamic routing, or I'm sorry, default routing, same syntax as the other ones. So what you're going to do is on router 0, you want to put this on your internet-facing router. Technically, this is the internet-facing router, but we're just going to assume that this is the ISP, and this is a web server behind it. So you want to get your information from here. Let's say, for instance, you're trying to get to a place that's not on here. So you want to get to 25.3. So 25.31.26.21. We're going to go config t and go no IP route. Now, what does that do? Well, that takes the static route out. Well, how do you get the information there? Well, there's this thing called the default route. We're going to go IP route, type 0.0.0, and we're going to type in 10.1.3.1. What is this saying? Well, basically, it's saying this. That we're going to say, in order to get any IP address on any subnet mask off of my network, we're going to use the 10.1.31 IP address. So anything that might be up here, we might have the 172 network or the 192 network somewhere over here. And in order to get it off of this network, in order for these guys to get out here, it's going to use this interface. So in order for this guy to ship information from here outbound, it's going to send it this direction. This guy's directly connected to it, so then it knows how to get there. So we're going to type in enter. And then we're going to go back to, we could technically pull up the switch, which has absolutely no config on it right now at all. And we're going to end, we're going to ping 25.31.26.2. See if that works. Nothing. Well, doesn't that just take the wind out of my sails? But how come you can ping it from there? That doesn't make any sense, right? Well, you know what? I think it still needs one. It might be a packet tracer thing, but I'll type in. We're going to put that in there anyway and see if it'll work now. You know what? I'm thinking, now that I'm thinking about this, I think it needs, in order to get to the 10.1 and the 10.2, We need static routes for those guys too. So we're gonna go IP route 0.0.0.0, wrong one. I need to go to router 1. Slide this guy back over. And we're gonna go IP route config t IP route 0.0.0.0 10.1.3.2. Let's see if that changes anything. Where's the switch? There it is. I don't know. I'm perplexed. You know what, for kicks, I'm gonna add a host. Be right back. Okay, I added a host. There must be something weird about pinging from a switch. Oh, you know what? There's no IP address on the VLAN, so it doesn't know where to ping from. There's gotta be IP addresses on both sides in order for it doesn't know where to send it back. So I'm gonna ping that guy. And success. That is how you do it. Now, I know I got hosed up on a couple things, and I added a few more things in here that I didn't plan on. But my point was, in order to get information from here to here, from this network to this network, so we're got the 1.0 and the 2.0. Assuming these are /24s. And this guy might be a 3.0/24. In order to get these routes right here, this way, you need to configure a route in order to get them to this guy. Okay? Simple as that. That is all there is to static routing. I've shown you how it works. If you have any questions, don't hesitate to give me a shout. rriker82@yahoo.com, rriker82@gmail.com. If you're a student in CCNA class or any other thing that you see that you have a question about, give me a holler. You have my email. I hope this has been informative for you, and I'd like to thank you for viewing.